they come up with wrong conclusions, like everybody needs to adopt Bitcoin. No, we don't. We just need a small portion of mankind to actually bring the price to $10 million. Imagine you have somebody making this prediction 25 years ago, 30 years ago, and Bitcoin is the empirical evidence that is true, that he was right. It goes beyond being just a model. So the power law is not a model. It's much, much more than that. It's a framework to understand what Bitcoin is, how Bitcoin works, the nature of Bitcoin, the nature of the phenomena. Tell us, it's really a rabbit hole where you can go in, and basically the idea is, I'm using all these tools from physics to understand Bitcoin. At a certain point, I changed career and I became a neuroscientist. I work at Northwestern University. The number of Bitcoiners, we don't get double the value, we get 4 times. So if we triple the number of Bitcoin, we go and get 3, we get 9. If we make 10 times the number of Bitcoiners, we get 100.
Thank you so much for coming back. I think the first episode was really good, and people actually loved it a lot. And but for the few people that might have not watched any of your videos, give us some brief overview of who you are and why you're excited about Bitcoin and what kind of the power law is.
Yes. So I'm Giovanni Santostasi. I spend most of my time in academia. I've been physics professor for several years in a small college here in the United States. I came several years ago to the United States. At a certain point, I changed career and I became a neuroscientist. I work at Northwestern University in the neuroscience of sleep. But it was a very interesting change for me because I entered a new field and I started to use all these tools from physics. This is a relevant things in terms of our discussion about the power law, because basically the idea is, I'm using all these tools from physics to understand Bitcoin, but I had experience already on how powerful these can be, because physics is really a way of thinking about the world from first principles. In fact, in one of my slides, I have I can maybe even share the slides. I have a slide about what Elon Musk says. This one, share. So he says, I tend to approach things from a physics framework, and physics teaches you to reason from first principle rather than by analogy. And this is so important, right? When I saw this sentence, why I put it in my deck, because it's a way of thinking about the universe, right? So in physics, we look at the analogy. We still look for analogies because it's this idea of universality. We look at different things that seem different, but actually they have similarities in common. Usually the similarity are in terms of their mathematical behavior, their principles behind, but we always, the idea of, first of all, notice here, right, it says framework. And this is what the power law is all about, right? My main contribution to the Bitcoin space is that I found this framework to understand Bitcoin that comes from a physics understanding of the world. And like I say, when I changed field from physics to neuroscience, it was very clear how powerful that approach was. I started to publish papers in the topic very quickly, even if it was a new field. I even have a patent in the field, within a few years that I joined this new field, like a beginner, simply because I had this new way of thinking about this phenomena. And then when I discovered Bitcoin was really early on, 2012, I started to apply the same ideas, same way of thinking about Bitcoin using physics tools. And it's very powerful because my main message, right? So just to explain what the power law is about for the people that maybe didn't hear about yet. And I'm surprised because even if, I don't know many interviews right now I did, but maybe 30, 40 interviews, including yours. But there are still people that don't know about the power law. It is surprising. But basically, the idea is that there is a particular way that we look at phenomena in physics. That is, so this book, actually, I suggest everybody to read this book. It's called Scale. It's a book that actually will open your eyes about one of the most important things that we are interested in physics, right? In physics, particularly, for example, when I was in astrophysics, we deal with a range of phenomena that cover a huge spectrum of what we call scales. What do we mean for scale? Scale is when you look at something and you look at how this phenomena changes in big, huge amount. Like, for example, if you have an atom, you're looking at an atom, and the atom is, the size of an atom is 10 to the minus 10, so 1/10 of a billion of a meter, right? And then you go to things that are like molecules, so you go a factor of 10 up. Then you're looking at grouping of molecules, and maybe go another scale of 10, right? So then you go to things that you can see with your eye. So we're talking about, from millimeters, then centimeters, meters, then objects around you that are bigger than humans, right? Humans are on the scale of few meters, right? You are 2 meters. Most humans are not 2 meters; they are a little bit less than 2 meters. But when you start to talk about houses, right? So we're talking about tens of meters, hundreds of meters, and then you're looking at mountains that are thousands of meters, and then you're looking at the planet Earth, right? Millions of meters, and so on, and then the solar system and galaxies and so on, right? You have all these different phenomena happening at many different scales, and you're trying to understand if there is some order and organization between all these. As you change scale, is there any principle that determines some kind of organization, some kind of a pattern? And so in nature, we found over and over again that these phenomena are organized, or they have some kind of pattern when you look at the scale of a phenomena. The scale is brought, right, I just explained it, is when you change, you go from meters to 10 meters, 100 meters, so factor of tens, basically. And one of the way mathematically to bring up the scale of a phenomena is to use this mathematical tool called the logarithm. And I know that this turns off a lot of people that maybe didn't do very well in math, they have bad memories about math, but like many things, the beauty of Bitcoin is that it allows you to study and revisit topics that maybe you put aside or you didn't find interesting when you grew up, right? And now, like in my case, for example, I never dealt with economics or concept in economy, and I started to revisit this topic because I wanted to understand Bitcoin, and I found it interesting, fascinating, right? Because now you're more mature, but then you see the connection with Bitcoin, that is something that all Bitcoiners are very fascinated, right? It's not fascinating simply because we want to make money with Bitcoin, but because we recognize it as a revolutionary idea, right? So we go deeper, we are trying to understand it, etc. And so what I'm trying to do with my studies and my work on this idea of a power law is to give a framework, exactly like we show in the first slide. It's bringing this framework from physics to understand the phenomenon of Bitcoin. And in one of the most important framework that we have in physics, we have a different, but I would say it's a central one in physics, because it's a unifying way of looking at the universe, right? So if we go back to the book, it says universal. So what universal mean? We can break down. All these words are very meaningful and used with a purpose. So universal means you have all these different phenomena that maybe seem unrelated, right? For example, how much energy an animal uses according to its size, or maybe how the planets are moving around the solar system, or how a city grows. It's not, this universality doesn't regard only physical phenomena, but also biology and even human beings, because that is one of the things that many times when I discuss this topic, I get pushback because people say, well, maybe planets can be described by mathematics, maybe biology too, but not human beings for sure. We are free, and so and this is also because a lot of Bitcoiners have read the Bitcoin standard that is based on Austrian economics, and a lot of Austrian, you're from Austria, a lot of Austrian economists claim that human beings are so free that mathematics cannot really describe it. I think it's more complex than that. I want to actually study more Austrian economics, but if you make it like that, or if you interpret it like that, it's really wrong, because actually human beings can be described by math. And this is why this book mentions innovation, sustainability, pace of life, organism, cities, economies, and so on. Because there are many, many human phenomena that are described by these scaling laws, because power law and scaling laws is basically kind of synonymous. They are the same thing. And so having this approach, understanding things through scale. So again, this is why I recommended this book, because it allows you to it goes beyond Bitcoin, right? And then if you eventually I will write a book like this. It's called The Physics of Bitcoin, where I show the relevance of this scaling thinking and framework to understand Bitcoin. But my work is basically, the essence of my work is this. Once you have this tool to understand the universe around you, you will be able to understand a lot of things that maybe you didn't understand before. And like I say, how do we bring up the scale when we're looking at phenomena? We use the log because, as I was explaining before, just to give a kind of a refresher of what the log is. So one way, when you're talking about a phenomena like a Bitcoin, right, when we can see the relevance of the other scaling phenomena. In fact, actually, before talking about Bitcoin, let's look at some of these scaling phenomena where power laws show up. Like, for example, one of these is this one, right? This one has to do with planets. So in this case, we are showing, I'll try to make it a little bit bigger, but maybe you can see it. So with planets, what we see here is the log of the distance of a planet. This semi-major axis means basically the distance of a planet. It's given in this unit called astronomical unit. That means the distance between the Earth and the Sun. So let's say you use that as your scale. So of course the distance then for the Earth will be one astronomical units. And then you can determine all the distance of the other planet as a multiple or a fraction of this distance, right? So for example, Jupiter is about almost 10 astronomical units, right? And Venus and Mercury, of course, will be a fraction of it because they are closer to the sun. And then, of course, the period of how much time it takes to go around the sun is given in years. And for the Earth, again, is 1, right? So Earth is here, 1. Now, I take the log. So the log, see how in this chart, for example, the scale, the fact that we are dealing with a scale, it's clear because we have 1, 10, 100. You see the emphasis is in these big changes in size. So one way you can understand what the logs do, if you write these numbers in terms of what is called the scientific notation, it is kind of what I did here in the Bitcoin chart once we are going to look at it. So 1 can be written as 10 to the power of 0, right? It's a convention. Then you have 10, it is 10 to the 1, right? If you write it as power. And then 100 is 10 times 10. So you write it as 10 to the power of 2, right? You're taking the square of 10, you get 100. You take the cube of 10, you get 1,000. You take the fourth power of 10, you get 10,000, right? A million will be the sixth power of 10. If you take the log, what the log gives you is the power. So log of 100 will be 2. Log of 1,000 will be 3. Log of 10,000 will be 4. And what is the usefulness of that? It's basically now you're rescaling by focusing on the change of the exponent. It seems strange, but for example, here in California, we have a lot of earthquakes. And so everybody's familiar with this Richter scale, right, for earthquakes. And so they use numbers like scale 4, scale 5, right? A change between scale 4 and 5, it's a big change because actually these people don't know. They use the word scale, right? Scale, Richter scale, but maybe they don't understand what is meant with that. Is exactly this, is that there are really changes in 10. So it's more complicated than that. But basically, if you're talking about 4, it's almost like 10 to the 4. If you're talking about 5, scale 5 is 10 to the 5. So it looks a small change, right, going from 4 to 5, but actually, because it's the power, it's the scale, it's actually a factor of 10. By the time you go to scale 6, we are talking about an earthquake that is 100 times bigger than a scale 4, even if a change between 6 and 4 doesn't seem big. So the reason why we do that is because many phenomena, when looked at from a scale point of view, seems to have some kind of organization. And for example, look at this graph with the planets, right? If I draw them in this way, where I take the log, so that gives me basically the scale, then it looks like a straight line. And what it means, this is actually, it's simple to show. If anybody has a little bit of knowledge of algebra, you will be able to show it yourself. I show this in one of my videos on a certain point in the book, and there will be some pages where I show how to do it, but I need also to make some classes probably about that. But it's relatively simple to show that if you have a power law. So a power law, just to simplify, it's something that looks like this, where you have y, so the quantity y is proportional to some quantity x to the power of n, right? This n, for example, imagine I say, okay, this quantity y is proportional to the square of x, right? So it will be y equal x squared. So if I double x, then y will be 4. If I triple x, then y will be 9, and so on, right? I make it 4 times bigger. 4 to the 2 is 16, 16 times bigger, right? But this n can be any number. It can be smaller than 1, it can be bigger than 1, it can be negative, that will mean that there is some kind of inverse relationship. But anytime you have something like this, that is the definition of a power law. It's called a power because you have a power, and it's a law because, and that is one of the things I try to explain to people over and over again, because since I started to talk about the power law, other analysts or influencers are starting to create their own version or variations. But some of them, they avoid using the word law. They call it the power curve or the things. I think to make it more appealing to people, because they think that law is a little bit of a put off. But actually, they are missing big time the most important message, that we are actually dealing with laws because it means that there is some kind of organization, there is some kind of mechanism. That is where the emphasis. Remember, framework. I really love that word from Elon Musk, because it gives you a way of thinking about these phenomena that it goes beyond being just a model. So the power law is not a model. It's much, much more than that. It's a framework to understand what Bitcoin is, how Bitcoin works. the nature of Bitcoin, the nature of a phenomenon. Tell us, it's really a rabbit hole where you can go in and you get lost because there is so much depth in it, right? And so this is what the main message of the power law is. And so what do I mean for orders? Order is this straight line, right? It means there is some kind of simple relationship, linear proportionality. So it makes actually this equation simpler because the equation that we just showed, it says, well, forget about this complicated equation that says there is some kind of a power. If you take the log of y and you take the log of x, now this relationship becomes simply a straight line. A straight line means there is a direct linear relationship between the scale, not the quantity itself, but the log of the quantity, so the scale, between one quantity and the other, the scale of one quantity versus another. And a straight line is one of the simplest possible relationship between two things. And so it says, as you change the scale of how long it takes a planet to go around the sun, you need to change also the scale of the orbit. And that change is not random, it's organized, right? And what it means that there is some kind of principle, some kind of law that describe this phenomena, that is the cause of this phenomena. It points to some cause, you see? That is the physics way. Physicists really care about why something happens, the cause of something, right? And in this case, what is the cause? Do you have an idea what it could be the cause of this organization of a solar system?
I have no clue.
It's gravity. It turns out that it's gravity. When this was discovered, this actually, by the way, was discovered by Kepler during the Renaissance in the 1600s. Immediately people understood that this could not due to chance. And by the way, this was a big discovery because people for centuries and millennia, they tried to find some kind of organizing principle through the planet, and they had all kind of superstition and astrology and all kind of things like that. This was one of the first evidence that the universe was mathematical, that it was following very precise mathematical patterns. So it was a big deal. And then it took almost a century, more than 100 years, for Newton. So Newton came in and actually explained that this has to do, he gave a demonstration, the proof is due to gravity. So if there is a force of gravity between the planets, and this gravity works in a certain way because, the force between the planet and the sun goes down with the square of the distance, and is proportional to the product of the masses of the two objects, the sun and the planet, then you can show mathematically with, he wrote an entire book that was like big like this, but he had to introduce a lot of concept and he didn't use modern mathematics. But with modern mathematics, you can write literally 3 or 4 lines and you show that if you start with gravity, you get this relationship. And the relationship is the distance is proportional to the period to 2/3. So it's amazing, that actually the history of science that gave us technology, all the things, including the computer we are using, started actually with the power law. These tells you how important these power laws are in understanding the universe. One time I found this shirt that says, it's a kind of an internal joke. I went to a physics conference. All what I got was a lousy power law. But to tell you how fixated we are in physics with these power laws, because they show up everywhere. They are kind of unifying principle, like the title of the book that we were looking up, right? Universal means you find them in very different fields, from the planets to biology to even human phenomena. To me, this book was very important. In fact, I started with a lecture that I heard from this physicist, Jeffrey West. The lecture is called The Surprising Math of Cities and Corporation. It's a 10 minutes TED Talk. This was while I was studying Bitcoin early on in 2012. And when I heard that lecture, I immediately understood the relevance. I thought, aha, Bitcoin follows also this pattern, this power laws, because I was trying to figure out, I noticed that it looked organized, it looked orderly, but I was missing the piece. Because, even if I was very familiar with power laws, I didn't know they show up in human phenomena. And this book does this, because actually even the story of this scientist, he started from the physical physics, from studying particles and things like that. Then he went to biology, where he found many power laws there, and then finally started to study human phenomena. At the end of it, physicists started to use physics to understand cities, economies, etc. There are entire branches of physics called econophysics and social physics. This is one of the biggest criticism I get all the time, because people say, hey, sure, okay, power laws apply to planets, apply to biology. When we had our interview, I mentioned this power law that is between the size of an animal and the much energy an animal uses. But they come up in things like languages. Like if you have, for example, this is called the zip flow. You see how this exactly when physicists use universal things that seem not to have anything common, like the motion of a planet, and languages have something in common with this power law organization. In this case, you get a power law if you take the most used word in a language, right? In English, I think is THEV, and you rank it first, right? Because it's the most used. When you look at the second word, okay, you look at whatever that is, and then you find out how many times is used, right, in a language. You take a sample text, etc. It's all probabilistic. So you organize the words in a language in that way, and it's not random. You will think it's completely random, right? Okay, this word is used, is the first one, but how many times it's used, it doesn't have anything to do with the second one, right? Yes, the second one will be used less, but you will think there is some kind of disorderly pattern, right? Not that. In fact, you can predict. You can say, okay, what is the third, the fourth, the fifth most used word, and you can calculate from this graph how many times it's going to be used in the language. That is that powerful. And then notice how it's incredibly similar between languages. Like you don't see it here because it's maybe small, but it's even dead languages like Latin or Chinese or Japanese, even Asian languages, Maya language, whatever, they all follow this very predictable and precise pattern. It sounds crazy, right? If you never heard about it. And then cities, right? So this graph is kind of similar to this. I look at the size of a city, so that will be the x-axis in this case. Again, I notice, see, ln means log, natural log. So I'm taking the log. Again, all these are power law, because in power laws, it's a mathematical trick that you use. If you see a straight line in a log graph, this is how it's called. You take the log of y and the log of x, and you see a straight line, it's a power law. You can show it very easily with some algebra, but that is the case. And so you see, in this case, I do something similar where I take the size of a city, and then I see how many of these cities there are in a certain countries. These different colors are different regions inside the same city and so on. And it doesn't matter which country you're looking at, they all follow these power laws over and over again. And in this graph, you see, you can use different metrics in a city, like the crime, the GDP, the income, the patents, and they all follow power law, straight line, right? You see, this is the log of whatever metric you're using, the log of the population size, power laws. This graph shows how space, how the city grows, how the space of a city, in this case, the the area a city occupies versus the size. Again, these are all log graphs. take the log of the area of a city versus the size, they follow a power law. Now, and it's not never perfect because data is always noisy, right? In particular, in this case, this is different. Notice how precise it was when we were dealing with planets, right? It's all because this is what happens with physical laws, right? It's much. This is another thing I need to explain to people. When physicists talk about law, we mean a pattern that is very regular, that happens. It's very difficult to break, because there is some kind of mechanism that underlines the law, but it's never 100%. It doesn't mean that it's written in stone. Even the planets, right? Even how planets move, as far as we know, it's just very likely that we are going to continue to follow this pattern, but we never can say in science anything is 100%. As you move from planets to metabolism, notice how the dots are much more noisy, right? They don't follow perfectly the straight line because metabolism and physiology in general is much more complicated than how the planets move, right? And when you go to language, there is even more noise and so on, right? So you're going to get fuzziness, right? So this fuzziness means it's not perfect, but you can see the general trend is there. It's a power law. It's a scaling principle. It means as you scale the size of a city, the area of a city also scales up. And I explained this in our previous talk. The exponent, here the exponent will be expressed in the slope. So the slope and the exponent are the same thing. Again, it's something that you can show mathematically. So in this case, you see they write the equation as a line, right? They say it's a constant plus some multiplier, some multiple times x, right? And notice all these numbers are less than 1. So in this case, very similar to what happened with metabolism. So the slope here is 3/4. It's very important to understand that slope because it's almost like a fingerprint about a phenomenon. Tell us something about phenomena. Here, the fact that it's 3/4 tell us as you scale the animal and make it bigger and bigger, you use proportionally less energy. If you simply double the size of an animal, you will double the energy, but actually you get a discount of 30% when you double. Because it's non-linear, this effect becomes bigger and bigger. By the time you go from the mouse to the elephant, you get almost a factor of 10. That is a big factor. It means that the elephant, because of this organizing principle underlying this phenomena, is somehow saving energy by being bigger and bigger. There is some kind of order, some kind of intelligence in the physiology that allows the scaling to be efficient. Same thing with the cities. This means that as a city grows, they are using space more efficiently because this number is less than 1. It means that there is some kind of economy of scale. This could be simply because the cities start to develop skyscrapers. We have skyscrapers, we have bigger, taller buildings, and that saves on space. You can have more things happening in a limited amount of space. But it's not, again, you will think, is there a mathematical law that tells us that how tall these buildings are going to be, right? Because it means you're going to have certain size of building or certain number of tall buildings, right? If there is a precise mathematical pattern. Yes, there is. So everybody that says that is not possible that human beings follow mathematical patterns, we have tons and tons of data which says otherwise. One time somebody challenged me and said, okay, cities follow these patterns, but what about history? For sure, history is not following it any math. It does. Like, for example, if you look at, it took me a few minutes, and I can find many other examples, but if you look at the timing between wars, for example, even that is a power law. How many the size of a war, a long time, how long it takes for a war to happen with a given size, with many people involved, in that war, follows a power law. And, wars is one of the most historical things that you can imagine in terms of, events that can happen. But there are many others. So, there is math all around us, and a lot of this math is a power law. So this is why I say understanding Bitcoin as a power law puts you inside this framework of understanding Bitcoin as if it was a natural phenomenon, if it was something that actually belongs to this huge universe of regularities and patterns, right? So it completely changes your way of understanding Bitcoin if you really spend the time to understand what we are talking about. I will stop here for a second to see if you want to comment or ask me a question.
There's a lot. I just want to give because we have done and you mentioned it in the beginning, a first episode. I want to just share that real quickly. I hope I can do that. I probably override yours. This was our first episode, so it's just like if you type in Giovanni Power Law, Robin Seyr, or like type in this title, you will easily find it. It's also like a very popular episode, so it's under the, I think, top 50 episodes on the podcast, something like that. Maybe on the top 30 even. And then there we went. I think we basically covered what the power law is, how it relates to Bitcoin, in like, what is it, over 2 hours. And so it's I think it's a good starting point, even though like now we know also a Bitcoin, the power law. I have a question. Is like a wealth distribution also power law, and could also even be the Bitcoin distribution between addresses be kind of a power law?
Yeah, so since we talked, right, I went deeper and deeper. And one of the main things I wanted to understand was, okay, remember I told you the slope of a power law of this line tell us about the power, and then the power is kind of a DNA for the phenomena, right? In particular, if it is above one, below one, different things are happening. If it is below one, it means there is some kind of economy of scale, like we just showed with the area of a city, of the metabolism of an animal. In the case of Bitcoin, the slope is 5.82, so it's bigger than one. And I wanted to understand where this 5.8 comes from, because if you want, usually when you find the power law, that is the starting point. It's not the end point. You go deeper, and you're trying to, like, for example, if you read this book, Scale, they have an entire chapter that describe what is going on, why in the metabolism the power is 3/4, and it's kind of really cool journey in trying to understand physiology, how the body works, how there is some kind of optimization in how the energy is distributed. It's a beautiful idea that it's worth exploring. So I knew that it was important to understand where these come from, this number 5.8 comes from. And I already discovered in the past these power laws that, in fact, the one in time that is the one that I show here in the bottom, right, where we are relating.
You have to share again. When I took over the screen, I ended yours.
Okay, I will do that. So, okay, we have this graph, right? So we are showing 3 panels. The lower one is the price versus the time, right? We are taking the log of the price versus the log of time. This is the more familiar power law that people have seen before. And like I say, the slope here is 571, right? Something close to 6. Now, as a scientist, you are asking yourself where that number comes from. What is due to? Has to be some kind of cause that is producing this behavior, right? So I already discovered these power laws in the past, but I didn't put them together in a coherent picture. In fact, this one with the addresses I discovered all the way to 2012. And what is telling us, right, in this case, we are having addresses as a function of time. And what, so we have the log of addresses and the log of time, right? And you see, it's a straight line. It's very close to a straight line. Like always, you have some noise, we know that in Bitcoin we have this bubble, so sometimes we go above, sometimes we go below. But in general, you can see it's even a better straight line than the price itself. Now, if you measure the slope of that line, it's close to 3.1. Now, what does it mean? So addresses are in Bitcoin, we have all this on-chain information. Addresses is one of the closest things to adoption that we have. It's not a direct measure because, and it's actually a good thing that, when you buy Bitcoin, somebody's not asking you your name and, your address, right? Your physical address, that would not be good. But we have this proxy that is addresses, right? So because to make some transaction, you have to create an address, you have to send it. So it's a measure of the activity of a network, right? And so if we measure it over time and you plot it in this way, it's clear there is a very precise pattern there. That is a power law because it's a straight line in a log-log graph. You measure the slope, it's 3. So there are a lot of consequences. One of these is, just by looking at this graph, is that Bitcoin, it's what is called scale invariant, right? So it means that it doesn't matter at which scale you're looking. If you're looking at the behavior in few weeks, in few months, in few years, Bitcoin has done the same thing because same thing means it followed this pattern. It never changed. That is something that it drives me crazy because a lot of these so-called experts, right? For example, when you hear Seyr talking about, or maybe some big entity like institution like Fidelity or whatever, and make this presentation, I saw several of them, right? There are these people that are some higher up in the company, and they are supposed to know this stuff very well. They say things that are not true. Like, for example, I don't know why, because maybe they don't have the right tool to look at, the right framework, like Elon says. They make these claims, Bitcoin follow an S curve of adoption, right? That is so wrong because you can see there is no S curve here. It's a straight line. What do I mean with that? They mean this, right? They mean if Bitcoin followed a bell curve distribution where you have early innovators that are going to be a small minority, then you are going to have early adopters, right? So this looks like a bell curve, like a kind of like height, right? Most people are here. Robin will be over there, right? In fact, outside the graph, right? So tall. We are feeding the memes, Robin. We are going to use your height as an example, right? So you will be over there, right? But if this was height, right? But here we are talking adoption, right? So early innovators, right? These are the crazy people that bought Bitcoin when it was on $1 or whatever. Then you have early adopter, early majority. You see here there is a peak. There is going to be a peak, and it also gives us some kind of scale, some kind of not scale, but typical time, right? There will be a certain time between the beginning and when we reach this late majority, right? And it's supposedly many people say we are not yet there. This is why they say, we are early, all these kind of things that are not the right way of thinking about Bitcoin. We are not early. In fact, in a moment, I tell you why we are late. We are almost done. This is what I say. If you look at it in the correct way, that is the mathematical way. So this is what they mean. They say, it's going to follow something like that. And why they say that? Because a lot of technologies, right? There are many graphs that show like the refrigerator, the bicycle, the car, etc. They were adopted in this way. There was a certain number of early people. Then there was a time when everybody was using it, right? That is kind of a peak here, right? Everybody at that point has a car. And then you're going to have less and less people because these are kind of the late majority, the laggards, right? So people that refuse to use a car or a refrigerator, and finally everybody does it, right? But this are smaller and smaller number as you go away from when everybody adopted it, right? Right now, if you're looking, okay, almost everybody in the first world has a refrigerator, right? There are almost no people that don't have it at all. Maybe the Amish, I don't know if they use a refrigerator, probably not. But so everybody's talking about this almost like a mythical event, right? When, there'll be a moment where everybody's going to adopt it, right? The majority of people are going to adopt it. And you see how the curve becomes kind of, here is a little bit less steep than they usually represented, but it's supposed to be kind of almost vertical here, right? So because the S-curve, what the S-curve represents, how is the S-curve related to this graph is nothing else than the sum. If you sum all these people, right, this is called, mathematically this is called an integral, but it's basically a sum, right? So you sum. These represent the total. These represents what is called a distribution. That means how many people from here to there, how many people from here to there, how many people from, right? Imagine these beans and I calculate how many people are in this category, how many people are in this category. This one is the running sum of everybody, right? And you see it goes up, it goes up, it goes up, and then when we arrive here, it kind of accelerates. If this curve was a little bit taller here, you will see almost a vertical S, right? And then as you add, see here it's kind of saturating, right? Because we are reaching almost everybody, 100%, right? And so as we reach that, it kind of saturates and then it flattens out, right? You understand this graph? You understand? Do you have any question?
Is a devaluation of a currency, so basically inflation, also then following a power law?
No, it's mostly exponential. That is another phenomenon. The exponential is when you have something that doubles or triple, right, that changes at a precise amount of time. So the time is constant. So imagine a bank account that compounds 5% a year, right? So as you compound, right, and you start with 1,000, and you have 1,005, and you have more money to compound, and you continue to compound, it will have an exponential. And what is characteristic is that the change is as a typical time frame, in this case, 1 year. And that is usually how inflation works, is an exponential. Here, we're talking about adoption that is also exponential, basically. So this actually is an exponential, both here and there. But it is different in the sense that if it arrives at a saturation point, right? There are all related phenomena.
Just to, because so the Bitcoin adoption follows a power law. Then when we have for example, inflation or like the currency that we are measuring the Bitcoin price in is kind of following an exponential curve downwards. How is then the Bitcoin price still following a power law if the underlying fiat currency is?
It's a good question, but hold for a second because I want to finish this topic about adoption and then we can explore that question. Okay, just give me a second. Okay.
Yeah, of course.
Yeah. So I understand your question and I will answer it. So, and notice that is my argument that there is no such S-curve here at all. It follows a power law. So it's very different type of adoption than an S-curve. The curve, you will be able to distinguish, even if we say, well, but it doesn't look an S-curve because we are not yet there. We are here. No, we are not, because if that was the case, given the math, you will have to go a little bit deeper in the math, we will not see a straight line in a log-log graph, because this means a power law, and if you have an exponential, it will start to look like curved. So it will not follow a straight line, it will look curved, the adoption, and instead it's a straight line. So it means it follows a power law. It means there is not this mythical time when everybody will adopt Bitcoin. That is a fantasy, it's an illusion, that it doesn't exist. It's actually a better message. You know why? Because instead of having this mythical event that who knows when it's going to happen, when everybody finally adopts Bitcoin, Bitcoin simply does what it's doing from the beginning. It doesn't need to do anything else, and it doesn't need to be adopted by a majority and nothing. Bitcoin needs to do what it's already doing now, to go wherever it needs to go, like, for example, to 1 million, 10 million, and so on. So it's actually a much nicer message. It means let Bitcoin do whatever it's doing. It's doing the scaling in addresses, and it's exactly what it needs to do to go wherever it needs to go. By the way, it turns out there are many phenomena that follow this power law adoption. For example, the internet. The internet is exactly that. I have a graph somewhere here where I can show how the internet and Bitcoin looks like. They are basically almost like parallel lines, because even the slope of this tree, it's actually, I try to understand where this tree comes from. Is one of the things I want to explore better in the future. But it's something that is very common. There are many different phenomena found. Other social networks, they grow with the power of 3. Viruses grow with the power of 3. It's not this. I'm just give me a second. I will find it. I have many slides, hundreds of slides.
Oh man, over 200 slides.
400 actually. But let me find the relevant slide because it's really interesting. Yes, this one. So this is the internet. You see, this black line is the internet, and they fit it with the red line that is, the regression for that line. Notice, and this is Bitcoin. The blue line is Bitcoin, and they are both straight line in this graph, and they are parallel. That means the slope is very similar. And in fact, for Bitcoin, is close to 3. It depends how you measure it, but it's basically a number close to 3. Internet to 6.3, very close, very
so
similar.
So Bitcoin is growing faster than the internet.
Bitcoin is going faster than the internet. That is amazing, but similar, right? That again, if you are a scientist and you see this similarity, you already know that it's not due by chance. There is some very precise process in how people organize themselves online, the interactions, etc., that make this phenomena very similar in nature. It's amazing, and there is no. This is why Bitcoin is not an asset. It's not gold. It's not silver. It's not, it's its own phenomena. It's this experiment that we are doing as humans. We are creating an alternative economical system, monetary system, where we are associating value with it, and it's its own entity. It's like a living organism. It's like a city. It's this clever, intelligent system. There are a lot of things that you're associating, consequences, because once you understand that it's the framework that tell us Bitcoin is alive, it has its own internal intelligence. This is what networks are about, right? If you're thinking what a network is, we study in physics network. Actually, Barabasi is another physicist has created almost the science of network. So we use a lot of tools to understand from physics to understand network. It's basically the definition is you have many different individual entities, like for example the cells in the body or computers or Bitcoiners, right? And then you have this whole where what matters is how the individual interact with each other. That is what makes different, right? So for example, if you have a gas, you have all these atoms that are moving randomly, right? And you can write equations to describe this behavior, but a gas is not intelligent, right? It's just random behavior of particles. But now if these particles start to communicate with each other, they start to exchange information, they start to collaborate with each other. Particles are too small, too simple to do that. But now take cells, right? You have cells that have their own internal operations, but then they talk to other cells and they exchange information. They do different things. They use resources. They work together. They collaborate. Now you have a network. That is what a network is, where you have individual plus exchange of information and coordination between the individuals. And, the internet is that, right? Because people communicate, exchange information, they organize, etc. And the characteristic of a network is that the behavior of a whole is much more complex and much more interesting and much more advanced than what the individual will suggest, right? If you look a bunch of cells and you put them in a container and they don't work together, they are just some organic material that does nothing, right? This is a dead brain, for example. But if you have a brain that is alive, where you have all the neurons communicating, exchanging information, you can have Shakespeare, you can have, Einstein, you can have whatever beautiful discovery of the universe, right? This is what networks are about. And this is what Bitcoin is. This is the relevance and importance of having a framework, because it's not a model. This is what I'm trying to tell. Oh, it's just a model. No, it's not just a model. It's a way of understanding Bitcoin that doesn't exist anywhere else. Nobody else has this understanding of Bitcoin. It's really deep. The only way, the only reason the video we had was not the most popular is simply because people, and I know it sounds arrogant, but it doesn't have anything to do with me. It has to do with Bitcoin. Once you have this framework, then this should be the most important thing about Bitcoin. Everybody should talk about this. Like, okay, if Giovanni or anybody, because I'm not just the only one, other people join this field of research, even if 1/10 of what Giovanni is saying is true, it's one of the best way to dispel anybody that say, oh, it's a scam, it's a pyramid scheme, it's going to crash to zero. All these things are answered by understanding Bitcoin as a network, but not just a word that people throw, but understanding that really we have a math to show that it does behave like a network. All these are network property. It's not a chance that the internet, that is the best network example, technological network that you can imagine, and Bitcoin behaving in the same way. Look at this amazing slide, right? So it's a demonstration of that. And so once you have this framework, you can answer all these questions. So if we go back to the slides that we are analyzing before, these three, this first slide tells you Bitcoin is growing like a social network. In fact, I found many papers that study different types of social networks, and they show that both the nodes, so the addresses are the nodes, right? Because are a proxy for the number of users, and the users in the Bitcoin networks are the nodes, what are called the nodes of a network. And then you can measure the links, that is how well connected all these nodes are. There are different type of geometry and patterns. You can calculate that. And there is a theorem, you can call it a theorem, but a theoretical result that says the value of a network, this is called the Metcalfe law. The Metcalfe law was developed by this engineer that is actually the father of the Ethernet, right? It makes sense. Is what connects the computer to the internet, right? He came up with this like late 80s, early 90s. And at that time, it was literally a piece of electronics that you needed to put in your computer, or maybe the IT person needed to do for you, if you were in a university, a company, whatever. And he was selling these little pieces of electronics for $1,000 each. And I saw a presentation that he made. You can find it online. And he was telling the story. It's really interesting because he was selling few of these units, and he was trying to do a business with this invention of him. And people will buy one or two, for company, for organization, for whatever, a university, a business, or whatever. And then, both because, of course, he was trying to make money, but also he was not telling a lie. He was trying to teach people the meaning of connecting things, like we're just discussing, right? The value of a network is not in the units, is in how they communicate, in how they interact with each other. So he was trying to tell them, listen, if you buy 10 of these units and you put it in your computer, now you don't have 10, you have actually 100. And why will he say that? Because if you if you look at all the possible connections of 10 computers, it turns out mathematically it's proportional to the square of a unit. So if you have 10 units, you're going to have 100 possible connections if you connect everybody with everybody else. And now, they will be connected to the printer. They will connect with each other. So I can send you an internal message, right? At the time the internet was developing. Of course, this applies even more if you have an external place to connect with, like the internet. You can do all kinds of search. Right now, these things are obvious, but at that time, people didn't understand it. And so if you have 10 people communicating with each other, where I can send you a message, or me talks to 3 of you, we make a little team. You can see that, right? You can see how much productive and how bigger of a value you get by connecting people, And so this is what he was trying to tell them, and his sales skyrocket because people realize, yes, the value is in having more and more computer connected. So if I have 10, I invested, it will be more expensive. I invested 10, but I really get 100 as my returned value, right? So he came up with this kind of, let's call it law, Metcalfe law, this is how it's called, that says if you have a network, take the square of the nodes, and that is kind of the value of a network. And guess what? If you take the price, that is the value of our network, and you look at how they relate to addresses, then what you get? You get a power of 1.77, 1.8, that is close to 2, that square that he was talking about. So Bitcoin actually is evident, because he said this theoretically, and you can show that it's true, that the number of links is the square of the nodes, but nobody ever had an evidence, a proof that the value really is the square, right? But Bitcoin shows that is true, that for Bitcoin, Metcalfe laws apply. It is amazing, right? That is, again, a power law, because we're talking about a square. It's not perfect, because any real system will not be like exactly that is an ideal case where everybody is connected with everybody else. But it's a number very, very close to the predictive value. That again, imagine you have somebody making this prediction 25 years ago, 30 years ago, and Bitcoin is the empirical evidence that is true, that he was right. So, and this is amazing because what it means that if we double the number of Bitcoiners, we don't get double the value, we get 4 times. So if we triple the number of Bitcoin, we're going to get 3, we get 9. If we make 10 times the number of Bitcoiners, we get 100, you see? And this is why when people say, oh, it's early, we are not early. So we are probably going up another factor of 100, right? So we go to 10 million before something big happens. I don't know what it is, maybe hyper-Bitcoinization or something, right? And that is going to happen in 20 years from now, according to the power law. Well, we need only 10 times more people to do that, right? If the price goes up 100, we need only 10 times. So right now, let's say that we have 100 million Bitcoiners, roughly. We need 10 times that is a billion. That is a fraction of all mankind. There are a lot of misconceptions with people, influencers, people that don't know the math of Bitcoin. They say, because they don't have, and they claim it, right, without any evidence or anything to back up their arguments, and they come up with wrong conclusions, like, everybody needs to adopt Bitcoin. No, we don't. We just need a small portion of mankind to actually bring the price to $10 million. Then what probably will happen will be some big event where, now Bitcoin is half of the entire value of the earth, of the wealth in the earth, and nations maybe at that time will adopt it fully. Maybe they will peg their currency to Bitcoin. Some big event will happen when we reach that kind of market caps. Now, how these things relate to the price versus time? Well, it's simply the combination of these two things. So basically, almost like Newton. Remember I told you Newton was able to describe theoretically why we see the Kepler's law. Well, I did the same thing. In a sense, I know it sounds crazy, but I did both the work of Kepler and Newton at the same time. The reason why we see these let's call it Bitcoin law, whatever you want to call it, in time, is because it goes like this, right? Price is proportional to the square. I wrote it here, actually. So it goes like this. So imagine this is the assumption, right? That addresses are proportional to the number of Bitcoiners. The Bitcoiners grow with the cube of time. Again, we are simplifying. We are rounding the numbers to make it simple. The price is proportional to Bitcoin squares. Bitcoiners is proportional to the cube. So I'm substituting here, right? And say the Bitcoiners they are simply proportional to the cube of time. And when you have, basically, it's like you have a power law of a power law, right? So you're taking the square of something that is has the power of cube. The way this works mathematically, you multiply the exponents, right? So you have that basically price is proportional to time to the 6. And that is why we see this power law with a number that is close to 6. Has to do with, these are actually two network properties. The growth that follows a power law. Many networks exactly grow like power law. They don't have an S-curve. They have a power law growth. And then the Metcalfe law, that is another network property, that tell us the value of a network is not in the nodes, but in the links, how well connected the network is. This is a measure of how well connected the network is. So it's really amazing thing, because now, again, we go deeper in the rabbit hole, and now we have a casual links. We are saying, hey, this observed behavior has to do with deeper, right? You are explaining a power law without the two power laws, but Newton kind of did the same, because even gravity is a power law, but it's a deeper power law because it goes deeper to the underlying phenomena, that is adoption that follows a very precise pattern. Now, why is cube? That we need to explore, because it's a never-ending journey, trying to go deeper and deeper. And we understand better Metcalfe. You can show theoretically this is what happens, right? Now, why is 178 versus 2? Again, has to do with the precise geometry of a network, So it's a really, really cool thing. I discovered, that there are many phenomena, like I told you, for example, viruses. In this case, is AIDS, but I know it sounds bad to say, okay, Bitcoin is like AIDS, but think about a virus of the mind, right? And so the mechanism of spreading and how it goes around and how it infects in a positive way, right? Because it's a good virus instead of being a bad virus, is very similar to how viruses spread. In fact, actually, they use network math to explain how you have the spread of a virus. There are many papers that use that. And notice, you see here, I don't know if you see it, I can zoom in, but 3. The growth goes with time to the 3. And it's not by chance. There are many other systems that grow exactly like that. We just saw the internet and so on. So there is something special about these 3. I need to understand it myself, why we have 3, why that happens.
The first time I ever made any money, I got myself from that money a watch. And ever since then, I collect timepieces to remember times where I achieved some milestone. That's why I got the Bitcoin 2025 edition when I went to my first ever American Bitcoin conference. So for me, the Bitcoin watches from Coin Vigilant represents the time that we are living in. For every person that wears a Bitcoin watch, I know they are representing sound money to the outside world. Make sure to check out those amazing Coin Vigilante timepieces down in the descriptions. I love those watches so much. I know how big of a hurdle it can be to have self-custody, but it's so freaking important to make that first step. We have to make sure it's as easy and simple as possible. And that's exactly what BitBox did. BitBox created the simplest and the easiest hardware wallet to use to get into self-custody. So get yourself a BitBox down from the link in the description. And when you use code Robin, you even get a 5% discount. The most important thing for your Bitcoin journey is not buying Bitcoin, but it's how to keep them. And yes, you have maybe the right tools, but how do you actually go ahead and stick it all together so it's the most secure for you personally? Self-custody is a deeply personalized journey. way. And the Bitcoin way is helping you exactly finding that correct setup for you personally. They are also helping you with securing your own cybersecurity. And if you want to go one step above all that, you can even get a consultation for a Plan B residency. Go to thebitcoinway.com/Robin and you will get a 30-minute free consultation. So you could say that Bitcoin is a virus that spreads and it's a natural force that will happen anyways.
Exactly. So there is something about Bitcoin and the nature, the message, the value proposition, right? Now, these were, for example, the finite market cap. That is for sure part of the value proposition, right? It's not a direct cause of how the network grows. It doesn't have to do with the fact that it's limited, but people find that attractive, right? The fact that you cannot be diluted. So it's indirectly a component of how Bitcoin works, but not directly. So this is also a very interesting graph. What I did here, I did different cuts of the addresses. So I look at all the addresses when I say anything above 0.1 Bitcoin, anything about 0.5 Bitcoin, and everything above 1 Bitcoin. And you see, they are all power laws. I call them with names, right? Shrimp, dolphin, crabs, and so on. So everything grows with the cube, but if you go to the largest addresses, they grow slowly. Like that makes sense because it's more difficult to find whales, right? So they grow slowly, they grow almost like linearly instead of growing with the cube. And so you see these are the more shallow lines, right? The steeper the graph, faster the addresses grow. But they are all power laws. They are all power laws. And now, when you're looking at the second graph, right, it was how the price is affected by the growth of the addresses. Of course, the steeper curve will be the whales, because that means, in fact, in this case, remember we say square. In this case, it's 5. So a whale, a change in whale, right? If we add one more whale, that will change the price big time. It makes sense. It's a whale, right? And again, notice we are all power law of different steepness. Steeper curve means more impact on the price. A small change in address creates a huge, big impact. But because they are growing slowly, when you combine them together, guess what? You get these red curves. And notice how the red curves all fall on top of each other. Basically, that is the power law. So this is a model that combines the growth of the addresses versus the impact of the addresses. They're all similar. That means everybody contributes the same. It is also very interesting, right? It doesn't matter if you're a dolphin, a shrimp, a whale, you're going to contribute equally to the growth of Bitcoin. And that also answers the question about people who say, well, will not ETF change this pattern because we are this big institution, we have a lot of money? No, because exactly this. Yes, we have a big impact, but there are few of them. And so when they are combined, they give us the same result. That is really cool. That, by the way, it's another demonstration, that we are dealing with a real phenomenon, because we have even a name for this in physics. We call multifractal, when you have power laws of power laws. So basically, it's power laws all the way down. There are power laws everywhere in Bitcoin. It's just so fascinating and beautiful, Another result that we found out is that really probably the main power law, it's really this one, is what we call the support power law. So if you look at, instead of looking at the trend that is in the middle, and you're looking at a deviation about 60% from the middle, you found this very powerful support line. Notice how the price basically almost never go below that. Even, see, this is COVID, right? This is COVID. Even during COVID, we basically arrive there and then we bounce back. There are many different ways where you can do it. I did here in a robust feed. If you kind of touches these points, but you can go 60% and you get all the different bottoms, in a very, very, so the bottoms are actually a precise pattern. And the reason why you have that, again, because everything here has a reason. There is a physical reason why these things happen. It's because the cost of production, if you calculate the cost of production, kind of aligns with that power law. Not perfectly, but very closely. So this is why we have a bottom. It's the cost of production of Bitcoin. And probably that is one of the main reasons why we have this scaling behavior. So it's not the only reason, because like we just say, this is how the growth of adoption goes, but it's all feedback loops. So basically there are, I don't remember if I show you, probably it was too early, I didn't have yet this slide, but there are basically 6 power laws, right? There is the growth of addresses, the relationship between addresses and the price, the growth of price over time, and then even hash rate. So hash rate, for example, is also a power law. It's a power law between price and hash rate, where it goes price equal hash rate to the square root of a hash rate. And hash rate grows as a power law in time. Again, it is not an S-curve. It's a power law. And they all interact with each other. And the hash rate has a very essential role in creating this support line, because basically it tells us when the price, first of all, usually we go there to these bottoms after coming from the top, right? So the market takes about 1 year to go there. The market is exhausted. Everybody we wanted to sell has already sold. But on top of that, now even the miners don't sell, because if they go below that, they will basically lose money. It will cost more money to produce Bitcoin than the price that they get by selling it. And so they stop, right? Some companies go bankrupt, they don't work anymore, but the one that survive, they take loans against equipment, or they raise fund or whatever, and they don't sell their Bitcoin. So basically the market can simply go up, they only can go up. And again, this is very unique to Bitcoin, because other assets don't behave in this way, not even gold, right? There is some cost of production, but it doesn't follow very precise patterns like that. Also because this is related to the difficulty adjustment, etc. So Bitcoin is very programmatic, and it has all these feedback loops that is another, if you study these things, it's another recipe for creating power laws. Power laws show up very, very naturally from any type of feedback loop, any recurrent feedback loop. Now, and there are very beautiful things about this, because a lot of the intuitive understanding that people have about Bitcoin, like for example, we know that it's resilient, the Bitcoin recovers, right? It can go down, it can crash, but then it recovers. All these are associated with power law properties. It's basically, I'm showing the math of a lot of things that people feel it in their guts, or they are familiar with Bitcoin by simply being a Bitcoiner for so long time, but they cannot express it in a scientific mathematical way. And this is what I'm saying, because you can show power laws are resilient. There are very precise mathematical way, a logical way, where you can say, given the power law properties, they are resilient. Like, for example, they allow for changes, but in the end, they tend to a very precise pattern, right? And this scale invariant behavior, like the fact that there is no point of failure, because it's basically another way of, maybe a way that people will understand better, scale invariance, right? The fact that there are many things happening at many different scale. And that is another way to say decentralize. So decentralize, it's similar as a concept to scale invariance, right? There is no one single place of failure. It's distributed. The phenomenon is happening at different scales. So if there is anything where at any particular scale where something fails, there are all the other scales that take care of this phenomenon. Like what happened with the body. The body can go through a lot of different environments, situation. You can handle cold, you can handle hot, because if something fails, there are other ways of doing the same thing, right? It has to be very, very systematic failure at all levels before the body gives up. It's a very, very resilient. We have a term in physiology for that, homeostasis, right? Bitcoin is almost like has his own homeostasis. You can change it, you can push it in one direction or another, but it wants to go back to equilibrium. That is the power law. So I'm trying to give you a feeling of where in this 1 year, first of all, we did follow the power law 1 year and a half ago. If you ask me, we are going to follow the power law in 1 year and a half from now. Yes, we did. In fact, we are on top of the power law. We are following it even better than before. But on the top of all this, I spent this 1 year and a half going deeper and deeper and deeper in studying Bitcoin as a scientific topic. And in fact, I'm actually ready to create an institute, a non-profit that is going to be a research institute. It's called the Bitcoin Scientific Research Institute. And I want to invite other scientists. We want to write scientific papers because independently of the power law, right, the institute will not be just on the power law. The power law gives us a framework, but it will be any type of scientific study to go deeper in Bitcoin, because Bitcoin is much, much more than just an asset, right? It's an experiment. It's an experiment of mankind where we are putting our resources together, our brains, our effort, our energy, and we are creating this structure that is much more than the sum of the parts. It's really like a living organism. It's has its own intelligence. This is what a network is. So yeah, I'm glad that we did this update, because there is so much more than we discovered, and we'll continue. We can go deeper and deeper in understanding Bitcoin.
There's a lot to cover. I feel like we started with the basics and we're now 1.5 hours in there. But I didn't forget my question with the devaluation of the fiat currency.
You're right. Yes, it will look like I skipped that question. You're right. Yeah. So the answer to that is this, and that is actually something that I try to explain all the time. I don't know if I am successful. Bitcoin needs to be anti-inflationary. Do you agree? Because if it is not, then it will be a failure, right? That is what Bitcoin is trying to do, is trying to be anti-inflationary. So if you're telling me that inflation has an impact, then something is wrong. And why doesn't? Because how much inflation can grow in 10 years? A factor of 2, right? At most, maybe 3, right? Maybe everything goes and it changes, right? It depends, because some things have a lot of inflation, other things don't, right? But let's say a factor of 2 in 10 years, right? Do you agree with that? 50%. You lost 50% of your value. It's a lot, right? It's actually, we are trying to exaggerate, probably less, but let's say 50%. Bitcoin in 15 years went up 100 million times. It's like you're saying, it's like what Galileo did, right? When he showed, listen, if I take a big stone and a small stone and I drop them, they are going to arrive at the same time. And people will say, well, what about the effect of air, right? There is some air resistance. They're going to affect a little bit. That is a rounding error. The two stones arrive at the same time. Now, if you have a feather, yes, the feather is much more affected by the air. So the feather, if I didn't have air, if I go to the moon and they drop a feather and a stone, they will arrive at the same time too. But in the presence of air, the air has an effect on the stone. It is minimal. It's basically, you can disregard it. So if you have a factor of 2 over something that changes by a factor of 100 million, it's nothing. And you say, well, okay, that is in the past. What about the future? Again, if I say in 20 years, Bitcoin goes up by 100, and you're telling me inflation will go up by a factor of 2, it's nothing. I can disregard it. Now, you can include it. The best way to include it is this. The power law tells you, and I have some disagreement with other people that have explored the power law, but I think they don't have the right approach. One of these, I don't know, without being personal, but APSK, he actually has an understanding where he includes inflation inside the power law. It's still a power law. You can actually show that if you include the inflation, it will still behave like a power law. But then it comes to some wrong conclusion about what that tell us. My understanding is this: these models having somehow baked in already inflation, and when you're making a prediction and you're saying Bitcoin will be $1 million in 10 years from now or 8 years from now, it will not be the $1 million of today. It will be whatever $1 million means in 8 years from now. So then maybe you need to go to 2 million to make up for that, right? So you want to wait for 8 millions or 2 millions, but it's not going to be 1 million and 2 millions are going to be close, right? So maybe it takes 8 years. We can calculate it, but maybe it takes 8 years to reach 1 million, and it will take 8 and 5 months, 6 months to reach 2 million. And then you compensate for that anyway, because 2 million will be the equivalent of 1 million now. It's just rounding numbers. When you're thinking in terms of 10, that is one of the things that people have difficulty to understand, right? From a scale point of view, you don't care about the difference between 1 and 2. Like me and you are, from a scale point of view, the same, right? Who cares if you are 2 meters and I am 7 something, right? It's the same. Do you understand? It's because what you care is, are we within 1 and 10? Yes, right? That is scaling. Are we on the size of humans? Are we in the size of a tree? No, right? Neither of us. Even you, as being 2 meters, you are not as tall as a tree. A tree is the next scale, right? 10 meters. Are we on the scale of a hill? 100 meters? No. As here on the scale of a mountain, thousands of meters? No, right? So we are talking about scales. So inflation is nothing, because Bitcoin is a scaling. That, you see, again, having the right framework can give you an answer to that question. Inflation, as bad as people make it, is not a scaling phenomenon. It goes up by a factor of 2 in 10 years. It's nothing. Bitcoin goes up by a factor of 10 in 10 years. In fact, it goes up by a factor of 100 in 20 years. Inflation will not do that. If it did, then Bitcoin will fail. Bitcoin is not doing what it needs to do. Bitcoin needs to scale up in that way, in such a way that it beats inflation, because it's a scaling phenomenon. It doesn't care. It says, who cares about inflation? It's a rounding error. Do you see that? Do you understand what I'm saying?
Yeah, the only problem a little bit that I have with that is like, and I don't know, like if you believe in that, like, what if the fiat currency is just going to hyperinflate?
Hyperinflation. Okay, let me tell you about that, because that is something that you have many guests discussing that, and I see a lot of young people discussing that. All right. And I'm going to write actually an article. In fact, because once in a while when I want to discuss this idea, I write an entire article to discuss it. Right? And my articles are both on X and on Medium, so people can go and read them. We can add it to the description of the video if you like. So I'm going to write an article that is called "The End of the World is Not Bullish for Bitcoin." That is the title of the article. And what do I mean? I literally mean, if that happens, it's the end of the world. So one, we don't want to happen. So I see a lot of people almost cheering this event, right? They want this hyperinflation event. I don't know why, because there is a misconception. I don't understand it, because you are Austrian. I don't know if I'm sure Austria had a similar situation like Germany during the Weimar Republic, right? I don't know if it was as bad as Germany, but I'm pretty sure something dramatic happened where, you needed a wheelbarrow of money to buy a loaf of bread. If I tell you your Bitcoin is worth a wheelbarrow of money, but this money is worth, you can buy a loaf, what do we gain? What do you get from that? There's nothing. I never understood that from people that make these claims, right? Like, oh, Bitcoin will be so valuable because we have an hyperinflation event. okay, will be valuable in a coin, in a money, USD dollar, that it's nothing. It will worth nothing. So I don't understand the logic of that. Maybe the logic goes something like, oh, if that happens, so many people will jump in Bitcoin, and that it will make it over the inflation, right? It will be so valuable that even beats that inflation. I don't know if that is the case, because if that happens, people will not care about Bitcoin. They want bread, they want water, they are worried about where we are going to sleep, what we are going to eat. Bitcoin needs a working society. And what we don't realize also, one thing is to have a hyperinflation in Argentina, that is a limited economy, a limited amount of people. And one thing is having hyperinflation impacting the dollar, that is an international point of reference. Almost every nation has tons and tons of these dollars. So it will impact the entire world. I really think that if anything like that will happen, first of all, it's not going to happen. So it's not going to happen because if we go in that direction, all the different nations will take actions and precautions. They will help the United States to avoid this disaster, because it will impact the entire economy. So the entire world will work to avoid that. One. Two, if it happens, right, you can imagine a scenario where it does happen, then Bitcoin is going to be the last of our problems. We are going to go back to some kind of primitive society, because there will be wars, there will be civil war, there will be probably even nuclear war, because maybe the United States decide, if I lose control of the dollar, I'd rather start a war. Let's nuke something and distract people from that, or create some kind of crisis. Something dramatic will happen, and then Bitcoin is not useful in that case. People in the Amazons don't buy Bitcoin. They are worried about other things than Bitcoin. Bitcoin needs a stable, working, functional society. And so, yeah, when people come up with scenario like that, I don't understand, first of all, why they are cheering, because you don't want to have Bitcoin being valuable relatively to a currency. And it's not going to be always like that, because yes, we all dream of a society where we don't even want to think about the dollar. We want to have only Bitcoin. But that is going to happen if we do it in an organized manner. So we have 20 years. That is why I'm saying also the other thing that many people say, we are early, we are late. We are not early. Bitcoin is going through 10 order of magnitude. We already did 8. So we have, if you are thinking in this framework, because I invite people to change their vision about Bitcoin and start to think about Bitcoin. Almost any questions that you have Bitcoin, think it in terms of scale. Because Bitcoin is a scaling phenomenon, and anything in Bitcoin needs to be understood through a scale point of view. If you're thinking in scale point of view, we only have 2 orders of magnitude. Even if it takes 20 years, it doesn't matter. For Bitcoin, it doesn't matter, because Bitcoin is its own way of thinking about time, of dealing with time. That is this time that slows as it grows, right? So for Bitcoin, the next 20 years, it's going to be like a few weeks, 10 years ago. It's the same thing. It's almost like a relativistic phenomenon, right? As you go faster and faster, closer and closer to the speed of light, time slows down for the observer. If you're seeing the observer outside, right? If you're seeing what happened inside that spaceship, it goes faster and faster. Time seems to slow down. Same thing with Bitcoin. Time is slowing down. So what happens is, if you're thinking in scale, we're almost there. So it will not take long before we arrive to some big event. Then yes, we are going to have some big event, hyper-Bitcoinization or whatever it is. It's very difficult to imagine, because it's mostly speculative. It's very difficult to even to think about how this system will work. But between here and there, everybody should want to actually have a stable economy, some inflation, because it makes the point that Bitcoin is a better thing. We need to substitute this dollar thing. Just let the dollar do whatever it did in all these years, being worse and worse and worse, but not to the point where we have like a crisis where people will die, where we risk some disastrous event like civil war or maybe even nuclear war. We don't want that. And when I say this, many people push back and say, well, one thing is what we want, one thing is what will happen. I don't think it's going to happen because, in fact, if anything, and this is maybe something that can be studied because we have data, Bitcoin is stabilizing the economy because a lot of resources, a lot of value is moving from traditional assets to Bitcoin. So it's becoming actually a stabilizing force. So maybe actually this is what doesn't allow the dollar to crash over time. But eventually, because the value proposition of Bitcoin is so much more powerful, we will change. And it will be basically a bloodless revolution, right? My son is in Estonia. They got free from Soviet Union without nobody dying. They did it in a completely bloodless way. And it's actually amazing. If you could do that, you can create a revolution without anybody dying, is the best way.
I think that peaceful revolution is and I love the point of it not like there's not a, if you imagine the Titanic, and if we say the fiat system, the US dollar, whatever you want to call it, is the Titanic, and we have a way to get to the lifeboat, the life raft, the land wherever this hyper-Bitcoinization is. We want the Titanic to sink as slowly as humanly possible.
Exactly.
So we have the time to build out the infrastructure at the land, and we have the time to get everyone there. And then there is, because I personally think if tomorrow everyone is in Bitcoin, the system breaks. I think we're just not ready for
we're not.
like transaction
and
fees of
the power law answer that question too, because it say, listen, give Bitcoin its time to scale, right? The infrastructure needs to scale. It's the same thing with the city. We cannot go from a city that is 100,000 to 1 million, because if it happens, it will be chaos. It will be chaos. Things will break down. There will be crises, etc. Right? One of the problems with too sudden immigration of people is exactly that. It's not that immigrants are bad. I am an immigrant, but if you're doing too fast, where there are no infrastructure, there is no way to handle everybody, etc., everybody suffers. That is a problem. So same thing, right? The beauty of the power law is telling, look, Bitcoin is taking its time. As it grows, it needs to grow slower, because that is one of the consequences of the power law, right? You have these diminishing returns. But the diminishing returns are not a bug, are a feature. We want to have Bitcoin taking more time to grow. And that is the way the nature prefers. There is a reason why tooth, nails, horns, shells, they all follow power laws, because nature over time found out that this sustainable growth is the growth that supports all these structures, that is the most intelligent way to achieve a goal. And it's amazing that Bitcoin in 16 years was able to find this pattern, that is a pattern of efficiency, of sustainability, of growth, that Bitcoin will have already collapsed if we followed an exponential. And this is what happened. If you look at this lecture that I mentioned, that is one of his punchlines. He says, cities are eternal because they follow power laws, and companies die. Almost all the companies studied. One of the things that this Jeffrey West studied is the trajectory of companies. They all follow power. They all follow exponential, and exponential are associated with things that die. The cancer is exponential. They grow, they consume everything around them, and then they collapse. While cities grow in this very proportional way, and they are eternal. He mentions Rome, right? 5,000 years old cities. Nagasaki, Hiroshima, cities that were literally nuked, and they came back to life. It's a beautiful, beautiful lesson. And Bitcoin is like this. It's like this city. So it's eternal,
Would it be better? I think Stephen, you 100% know Stephen Paranoid.
We work together. We work together. We have a show together.
And he brought this in the, I think the last show I did with him, he brought this power law of Bitcoin measured in gold up, and I really like that because it's like the old sound money and the new sound money kind of, and gold is like you cannot manipulate the supply as easily as the manipulating the supply of the US dollar. So I really like the seeing the power law in gold. It's also fascinating that we see it in US dollar, but is maybe like measuring Bitcoin's price in gold more efficient because it's like more connected to nature with gold being an actual thing?
In a way, it doesn't matter because how do you get the value of gold? You get it in USD, right? So all you in the end, you always go back to a USD. But when gold has its own growth relatively to USD, it's really not much of a growth. I know that recently it jumped, but if you're looking at a long period, if you look from a scale point of view, Bitcoin, if you plot, for example, um, Bitcoin versus time and gold versus time, gold looks flat, looks almost flat because it has no change, right? In fact, actually, is one of the things that people sometimes push back. You say, "Oh, gold is a store of value because it doesn't change." Somebody even calculated that if you go all the way back to the Roman Republic, Roman times, and you calculate the cost of a nice, uh, Roman dress, Roman cloth, it costs more or less what it will cost you to make a very nice tailor suit in gold. It's the same price. Certain things are changed, like a chicken, because it's much easier to make chicken nowadays, so it doesn't cost almost anything to buy an entire chicken. It was very expensive in Roman times, but very valuable things like clothes, handmade clothes, have stayed stable in time. So it's a useful way in the sense that it shows you can take almost anything. You can take gold. In fact, this is what this graph shows. Look at this. Gold. So in this case, the power law is inverted because we are showing the value of these things relatively to Bitcoin. So they are basically upside down power laws, right? So it's no power law in time. It's how these things loses value relatively to Bitcoin, right? How many of these ounces of gold you need to you can buy with a Bitcoin. The value of these things relatively to Bitcoin, basically. Um, and you see it goes down in time, right? Everything goes down relative to Bitcoin. But we are all following the power law. It's just that notice how the exponent is negative, right? Because it's kind of inverted. You understand the idea, right? And they all look power laws. It's just that the exponent is slightly different, 5.58, 5.91, 5, 5.31. These tell us that this scaling behavior doesn't depend on the things that you measure it, because it doesn't matter the exponent, it matters that there is this scaling behavior. The scaling behavior, this again, it shows that there is something universal in how Bitcoin works. It doesn't matter how you measure it. You can take any type of measurement, because it doesn't matter if you measure the size of Earth in meters, in feet, or whatever. You're going to have different numbers, but the behavior is the same. And so it's universal. It's a universal way of showing. It doesn't matter how you measure it. You can do it with gold, oil, SP500, even real estate. It's going to be a scaling behavior. That is the beauty of doing it in that way. But I don't think there is anything special, simply because gold has been kind of stable. So you can say, okay, it's more stable way of measuring Bitcoin. But it doesn't give you, I don't think it gives you much deeper insight. It's just another way of looking at the same phenomena. Uh, and it's nice that you can actually do it with almost anything, that is valuable. You're going to see the same type of scaling behavior, 8 order of magnitude, Bitcoin gold, changing value by a factor of 100 millions, no matter what you're using. So, and because none of these things grow orders of magnitude in few years. That is the main point, right? And so basically everything looks flat relative to Bitcoin. If you plot it in this thing versus time, right? In this case, we are plotting it as the value of that thing relative to Bitcoin. So we are going to look like we are losing value over time. But we are doing it in a very precise, predictable fashion. That is the main message.
Super interesting, man. It's always when we have growth and we can measure this growth in adoption, and we can actually, and it's something human, and I want to touch on that because you mentioned it I think twice or three times now, that we humans, we always think we have a lot to say, we're very centric, and we're like, oh, but we have a free will and all those things. But in the end of the day, we adopt this idea based on the power law, and we don't have that much of a free will because it's like the sound money. It's a natural force. And I think people push back on that point just because they think everything is human centric. The world lives around, and I always love talking with scientists because they understand that humans are like that small microscopic thing on the bigger universe, and I think there's bigger forces going on than the humans.
Yeah, and this is why I have this slide, because Galileo, and it's not that I'm considering myself a Galileo. I'm inspired by Galileo, right? He was Italian scientist, and this Galileo figure is looking at Bitcoin through the lens of a telescope, right? It signifies science and measurement and logic, and this framework where you put Bitcoin in the bigger constant context of everything else. And this is my point that Bitcoin is this universal phenomena that looks more like nature than a human asset, because a lot of these assets are, they are random with some maybe drift that is inflation, but not much more. There is not intelligence, there is not depth, there is no organization, right? And Bitcoin has all these things. And when you have this organization, when you just let this thing behave by itself and it grows and it does whatever it needs to do, it tells you, you're not in control. But yeah, humans, in particular, if you are not aware of this new development in science, how we are starting to apply physics to understand human phenomena, they think, there is nothing that tell us how we behave because, we have free will. But free will, I do think there is such a thing of equivalent of free will, but it's more of an individual level, right? When we work together as groups, then the exchanges, we became networks. We became networks, and then, the interactions, the activities, the global behavior, it follows the patterns of all the other networks. With the difference, right, this is what I explained before, as you go to more and more complex things, right, we are not as we don't behave in a perfect mathematical fashions like planets. We don't even behave like metabolism, because metabolism, again, is these little cells that are, sure, they follow certain mathematical laws, but, they still are relatively simple entities. We are more complexity, right? This is why when you look at cities, much more noisy, right? It's much more noisy. But you cannot say this is random, There is some level of randomness, but there is a pattern, and you can learn from this pattern. I think this graph is very nice. It's telling us as people make bigger and bigger city, they organize the space around them in a more efficient way. They build skyscrapers, taller buildings, and they are more efficient in how they use the city. This is why cities are so powerful, right? Most of the activity, economical activity, happens in city. Most of the patents, discoveries, etc., they happen in city. There is order, there is organization, and this is a human activity. You cannot say it's random. There is some level of randomness because, one city maybe did it better than another city. There is still some individual, effectiveness and results. So this is, expressed by the randomness in this graph, but in general, we are still following a very precise mathematical pattern. And notice all these R squared, right? 0.65, 0.71. Bitcoin is 0.95. It means that the organization and order of Bitcoin, even with these huge big bubbles, is much bigger than typical of these other phenomena. It's really unique. It's amazing.
The last thing I want to do with you before we come to the end routine is something practical, because I think a lot of people are not aware, and I think it was actually on a slide that you showed that you can calculate very easily the power law and what the price should be with the number of days, how long it has been, and yeah, exactly that slide, and maybe that's interesting because I think most people aren't that much aware, and we always think like a lot of people know all those things, but they actually don't.
So one thing we can do, if you like, we can calculate the price today, what the equation says, what the price is today. And the way to do it, everybody can do that, right? The first thing, you can, if you want, you can do it with me. I know that you say that you don't like, you didn't like math, but let's try this together because it's not very difficult, right? So you can Google and say, how many days, so that is the first thing we need, how many days from today, and you can use ChatGPT or whatever today, how many days today from January 3, 2009, right, when Bitcoin was created. And usually it gives you a day. So it's today is 6,009. I don't know if you got the same number, if you tried. So we actually can add it to a slide. We can do the calculation together. In fact, I will write it down here. Insert text box. So today is 6,009 days, right? Today is 6/17 from 2025, okay, from January 3, 2009, right? And it's very easy. People can simply Google this. The way I do it, I simply say how many days today from January 3, 2009, and you get a big answer here. The AI calculates it for you to 6,009 days. Okay, so then we go back to the formula, and according to the formula, we have that the price is equal to 10 to the minus 17. What is the relevance of this minus 17? It's a very small number because if you put 1 here, right, so of day 1, you take the power of anything, you take 1, if you have 1, you take the power of or whatever, right? So 1 to the power of whatever is always 1. So that means the day 1, the price of Bitcoin, according to this formula, was 10 to the minus $17. That is basically 0 with 16 zeros, $1, right? But nothing, basically it says, okay, day 1, Bitcoin was worth nothing. But what happened after 6,009 days? Okay, I take 6,009, I take this power, 5.83, and you can use a scientific calculator. Sometimes, I even do it in the browser. The browser can, if you use the browser, it can calculate that for you. So if you take 10 to the minus 17, right? I'm doing it in the browser. Times, I take 6,009, and then I take 5.83.
I think we only see the PowerPoint thing.
I can share that, but I'm just putting in the browser. I will write down here. I'm copying and pasting. I'm putting in wherever, when you do a search in the browser, you can, I don't know if you ever try, but it can calculate stuff for you. Price equal, and if you do this, I can show you how it looks like in my browser in a second. In fact, let's do it right now because that will be a big reveal. Okay, let me stop sharing this and then sharing again. Share screen. It's a lot of because maybe I should. Do you see now this? You're able to see it because do you see my
Yes.
browser?
Yeah, I see it.
Okay, so this is how I put it in here. Say 10 to the minus 17. This is how you write it with this caret sign. It means 2 times 6,000, 5.83. Look what you get. It's $107,250.
Almost exactly the price. We are now at 104 and $400.
Yeah. It's not crazy.
It's super crazy, man. It's like that accuracy, and it has been there since what 8 years now, or 7 years, or something like that.
Yeah. It's the same formula we have used for many years now.
Man, and basically also because people are always asking, oh, like when do we reach the million? When do we? You can just basically expand the days, and then you see kind of like what's
you can try different days and see when we get the price. Or if you want another formula, I can show you that people can play with. Let me do that. It's actually easier than what we just did. So one formula you can use is this, right? So let me write it here. So we basically say 107, right? We'll say 250. Okay, let's try this other formula. So imagine I want to know how many more times Bitcoin is going to be valued in 20 years from, or 10 years from now, or whatever, right? So you do this. You take this ratio between the time you're looking in the future. So right now, Bitcoin is 16 years old, right? In 10 years, will be 26. So you write down the age of a system to whatever, right? 10 years from now. You want to project it 10 years from now. In fact, right, we say it was going to take 8 years to be 1 million. So that will be 8 years from now. That is, we are now 16. Bitcoin will be 24 years old. Do you agree? 16 plus 8 is 24, right? Bitcoin will be 24 years old in 8 years from now. Do you agree with that?
Of course.
Okay. And then you divide it by the current age. So you can do this at any time. Take the future date, the future age of Bitcoin, you divide it by the current age, and then you're taking that power, 5.83. You take the same power. If you do this, you can also try, again, I use you can use a calculator, or you can put it in the browser. So you do, okay, and you do that ratio. It is 21, no, sorry, we say 24 divided 16, 5.83. So that is 10.63. 10.63. So Bitcoin will be 10 times, right? Let's round it to 10. 10.63 times more valuable than now. And right now we are okay. So that means in 8 years, we are what? Basically 10 times more, right? 10, almost 11 times more. But let's be conservative, 10 times, that is 1 million.
I think if I put it in, and if you take it exactly, it's like 1,140,000, but like around 1 million. That's amazing.
So this is what it says. So it does work all this time. I'm pretty sure it's going to work for 2 orders of magnitude more. So it gives us a feeling of where Bitcoin is going and a long time to take it. And some people don't like that because they don't want to wait 8 years. But remember, it's not about you. It's about Bitcoin, right? And Bitcoin knows better. Bitcoin knows that, cities are eternal and they follow power law. And this how, it's not that there is, Bitcoin is a person and is thinking. It's this collective intelligence, right, in the system that found what nature found, and it took billions of years. That is the other amazing thing. Evolution took billions of years to actually found this pattern of power laws. As I told you, you can find it online. There is an article that talks about how shells and horns and thorns, they all follow power laws. And there is a reason. There is a reason because evolution selected this growth as kind of a least effort type of growth, the one that is more efficient, that uses resources the best, and so on. In fact, you can make a plot. I have a plot here, that shows that the growth of a task of an elephant over time. It's a power law, and in fact, you could use it as a diagnostic tool and say if an elephant does something else, probably there is something wrong with the elephant. This graph you see here, a radius of a side. This is the radius of a task. The blue is the male because that's bigger task. You see, it's a steeper power law. That means it grows faster, right? Males they use a task also for fighting, for kind of love rituals or whatever it's called. And the pink one is the female. They are both power laws because remember, we are dealing with the power law given it's factor of 10, right? 5, 10, 50. This is the age of the elephant. That is another thing that people that don't know about power law is say, but you don't have power law in time. This is a power law in time. This is exactly that. It's like Bitcoin, is the task of an elephant grow like Bitcoin with the power law in time. And you see, they scale up. It's a scaling phenomena. And it's predictive because you could look at the growth at age 10 and extrapolate this growth. And people could say, well, the past is not indicative of the future. Yes, it is if you're dealing with a scaling phenomena because the underlying mechanism is the same. It's not going to change. And you can predict how big the task of the elephant will be at 20, 30, 40 years, whatever. And if it doesn't fall, there will be variability. Maybe, there was more food available. It grew faster during the time and there was less food. Here, maybe it was some kind of, lack scarcity, whatever, But in general, it follows this pattern. You can simplify with that line. And it's predictive because you can tell, given the growth of the elephant at any given point, how it's going to look in the future. And this is nature. Nature found this to be the best way to grow things in animals because, it takes resources, energy, it takes, minerals, etc., to build this task. And nature wants to do it in the best possible way. And it took billions of years to come up with this. Bitcoin did it basically from the start, because there is intelligence in how we operate, how we interchange, how we discover the price. It's really fascinating. If you stop for a moment and really think about this deeply, then you realize, wow, this is the most fascinating, most beautiful discovery about Bitcoin ever. And it's not about me, it's about Bitcoin. I'm trying to communicate how beautiful Bitcoin is. I was lucky to discover this thing. I was blessed. It's very humbling. It's not about arrogance. It's about how beautiful Bitcoin is. Look at this: a universal power law for modeling the growth of teeth, claws, horns, thorns, beaks, shells. All power laws. So Bitcoin, it's like this. It's nature. There is cleverness and beauty and intelligence.
How has it actually been for you? I've watched you the past 1.5 years being in the space, being sometimes hated on, loved on, being criticized, being cheered on, like both directions. I see a lot of people. It seems like everyone that I talk to, he has either a good or bad opinion on that. You're almost a controversial figure. How has it been the past years for you being in that space and having also I remember the British Huddle spaghetti thing and all those kind of iconic moments. How's it been for you personally?
In general, if I had to sum it up, amazing, because first of all, for every troll, there are 10 people that it's like a silent majority because they are not loud on the comments. They don't say things there, but they DM me, and there are a lot of people that tell me, Giovanni, I was on the fence before listening to what you have to say about the power law, and now you orange pill me. A lot of people, that continuously DM me, even today. And it's amazing, that is really, as a Bitcoiner, is one of the best things that you can imagine, that there are other people that get some value from what you're producing, and there is some deeper understanding of Bitcoin that increases their conviction, that makes them understand Bitcoin better. And so there are a lot of people like that. And that is amazing and beautiful, and very humbling. There are, beside all the things like people recognize me when I go to a conference, stopping me, etc. But that, it's a ego thing, and it's fun, but it has its limited value. But so it's in general has been super positive, and I'm doing a lot of progress in understanding Bitcoin, in having people like Steven, for example, working with me. We are doing the institute, so there is a lot of progress. But there is also a lot of frustration. Like, for example, I was not invited to the Las Vegas conference, and it's extremely puzzling. And again, it has nothing to do with me as an individual. It's just like, why will you not want to know that Bitcoin grows like shells and thorns and horns, and there is this incredible order and beauty in nature, and Bitcoin does the same. It's not something that you want to have at least a panel or some discussion about these, and you want to explore, even just as a possibility, and I don't know why some people, in particular some OGs that think they know everything about Bitcoin, they are pushing back. I think it's a combination of things, from ignorance. I'm sorry if it sounds arrogant to say that, but it's literally that. It's ignorance about a fundamental topic. Did they ever read an article like that? Do they know how to calculate a power law? Do they understand the relevance of power law? They don't. Most people that say these kind of things, they don't have a basis. And then there are some people that ideologically are against, I don't know what, like that Bitcoin is predictable, maybe, because we like that. Yes, it goes up, but maybe in an unpredictable fashion. And then there is a group of people that we like this explosion. We say 8 years for $1 million. I would like to be next year, not 8 years from now, right? And it's very selfish, and it's also very, again, ignorant, because it will be actually negative for Bitcoin. Like you say, if imagine you have this city, and all of a sudden there is a, I was in Baton Rouge when we had the flood, when we had a Katrina in, I don't know if you know, because you lived in Europe, but Katrina was it affected New Orleans. It is about 1 hour from Baton Rouge, where I lived. And we had all this influx from New Orleans. The city doubled, Baton Rouge doubled in a matter of weeks or months. And it was chaos. It was not very good for the city. Now, the city eventually adapted to that. But, we are talking about two. If we are talking about going from 100 to 1 million, that is a factor of 10, it will be destructive for Bitcoin. So people don't understand these kind of things. And, and it's part of, look, Galileo. It's not, again, people think it's crazy if Giovanni makes analogy with Galileo, but, Galileo was in house arrest. It's not going to happen to me, because, of course, it's different times. We don't do that, right? But when you introduce a new idea, basically a new paradigm, a change of framework, people resist it, right? And I don't know, it's part of the process, I guess. But yeah, it can be very frustrating at times when I deal with that, because look, I am a professional. I have worked for 30 years in this field of understanding the scaling behavior. I'm not saying to trust authority, but you see, we just verify, right? It's the contrary, because science is all about verify, do not trust. That is the beauty of science. Everybody can reproduce these results and study and go deeper. But people don't do that. The people that do it, like, did you interview Pius? Did you interview
Yes,
him?
I interviewed Pius, the banker.
Banker, right?
He is fascinated with the power law. I
Yeah,
went
exactly.
on a dinner with him afterwards, and he's really into it. Like in the podcast, we didn't talk that much about the power law, but on dinner, he was like he's super fascinated about it, and I think it would be fun to get you
Yeah, maybe we should be
both together.
together. Yeah, maybe you can interview. That would be a really cool idea of having both of us, maybe three of us with Stephen too, right? I'm going to invite him, in fact, in my institute. He will be one of the advisors if he is interested. But he has a very interesting background, right? He has a PhD in mathematics, and also he was an investor banker. He was familiar with all, the traditional finance, etc. And he literally loves the power law. It's not just fascinated. He had actually interviewed. What is the name of that Austrian Bitcoiners that has a very
Nico Jilch.
Nico, yeah. He had an interview with him, and half of the interview in that case is about the power law, right? Because he thinks he said it literally changes his way of thinking about Bitcoin. So you have things like that. You have Stephen Perinovet, he's an Harvard astrophysicist. You have Pius the banker, and many other people that have the background to understand what we are talking about, and they went down the rabbit hole, and they have no doubt they understand that it's the most important thing in understanding Bitcoin and maybe finance in general, right? And then you have people that don't have a background, they don't understand it, and they push back, because this is what the internet does, right? There are a lot of people that they think they don't think they don't. So it's part of the process. I think in general, it's positive. It's wonderful. Even with the frustration, because like I say, for every troll, there are so many other people that appreciate, understand it, that like it. And in the end, it's not about me. I want to communicate the beauty, the depth, the significance of Bitcoin. And I think this gives us the right framework. It's grounded in data, it's grounded in fact, it's not an opinion, it's the opposite of an opinion.
Yeah, I just want to quickly for the people that have access to the video. This is Pius in the podcast with him. So this is the English version, and I almost have no German speaking in my audience. I think it's like 5%. But if you just type in Pius Sprenger and then Nico Jilch, because it was a really successful one, it got like 40K views, and Nico has I think like an account with 20,000 subscribers. So like 40K is like really like a really popular video. And there they talk a lot more about the power law. Like if you see even like this first short screenshot is literally a power law in the picture. But of course, like most people probably don't understand it, but they can even at the captions. And yeah, it would be fun to have Stephen, you and Pius in a chat and do like a panel. I think that would be honestly Bitcoin Prague or like Bitcoin 2025 in Las Vegas. Then 2026 is the next one now because 2025 is over. It would be really fun to have like Stephen, you, and like maybe Pius or someone else like as a panel. Maybe in 2026 I will bring up the idea to them and I moderate it and you
you could be the moderator and we could have 3 or 4 of us that are working on this.
Would be really cool.
And they were really, and I think it will be a lot of people will go there because one of the things I heard about, I love a conference because it's a way of meeting other people. And there is something to learn, but if you really are super honest, I heard a lot of people say, well, besides cheering this or cheering that or that occasional announcement about some initiative, it's not really, there is not much to learn, there is not much informative material. And this will be very informative for people, right, if we did this. And this is what they told me. We had a parallel event during the conference where, I presented. It was, first of all, it was amazing because it's different to talk in person to people, and present this while people, react in the audience, etc. the people that attended, they came back to me and said, listen, I went to different talk at the conference, but this was the most relevant, the most interesting, it changing my way of thinking about Bitcoin. So, it's great. So we should do that. So maybe you should propose to the organizer to have such a panel, maybe, in Europe and maybe also in Las Vegas next year.
Awesome. Yeah. Let's do it.
Maybe people can comment and they can comment in this video and say if they would like to have such a panel with me, Pius, and Steven, and discuss all these things.
I think it would be awesome. But to come to the end routine of the podcast, we have two more questions. The first question for every returning guests, I always ask, what have you learned since you have last been on the podcast outside of Bitcoin? And for you, I will add outside of the power law.
in related to Bitcoin, right?
What have you learned since the last podcast completely outside of Bitcoin?
I started to listen to a lot of these videos about how people react to knowledge in general. In particular, I followed, I don't know if you are interested, but or if you follow at all, there is this individual called Graham Hancock. He's like a pseudo-archaeologist because he's talking about how these ancient civilizations couldn't build the pyramid. They could build this pyramid in Mexico, in Egypt. Had to be some kind of other civilization, lost civilization. And I see how people are fascinated by that because it's a story that seems to make sense to them. But, there is a lot of imagination involved. It's almost like a fairy tale, right? And people like Graham Hancock has literally millions of people follow him. And then there are the scientists, there was this scientist, Flint Dibble. He went to Rogan to actually debate him, and he got a lot of pushback. Some even really bad people telling him how horrible he is. Like the guy is fighting with cancer, that he should die, all kind of horrible stuff. And it was really interesting because I see a lot of parallels, between, it's not as bad, but, this fascination with things that are not scientific, that are fairy tales, like we have in Bitcoin. We have a lot of fairy tales, like, the God candle, the Omega candle, all these irrational things. And, or, even the Weimar Republic, where everybody's going to be millionaire overnight, if we have these are fantasies, and I see a lot of parallels between the fascination that people have with this stuff and how people that really do education, they bring science, they bring logic, they do have their followers and they have their appreciation because this guy, Flint Dibbles, has a lot of people that appreciate what they do, but it's a small minority in comparison with the garbage, So this is one of very interesting phenomena that I observed recently, and it's interesting to see and understand, why people have this fascination with fairy tales instead of the truth. And Bitcoin, see, to me, Bitcoin is about truth. It's about reality, and whatever Bitcoin does, but learn from reality. Reality beats everything. The beauty of Bitcoin is that it is real. It looks like a fairy tale, but it's real.
The truth is sometimes hard to swallow. That's for sure. We have an end routine. It's been a pleasure already, but we have an end routine in the podcast where the previous guest is asking a question for the next guest without knowing who the next guest actually is. And he asks you a very random question. But the question is, what is the longest you have gone without sleeping, and why did you do that?
I did. I didn't in my life in general or recently.
Oh yeah, like in your life in general, or whatever you can remember.
I didn't sleep an entire night, right? I skipped sleep, and the reasons can go from, unfortunately, playing video games to because I do play video games once in a while to relax. Usually strategy video games, where you have armies fighting against each other. But few times I did it because I was spending all night thinking about Bitcoin, thinking about where that tree comes from, what is going on. One night I didn't sleep, and this is when I discovered this connection between addresses and the price of Bitcoin. I was chatting with the people online. There were, we were having very interesting discussions. Some people were giving feedback, and then I started to put it all together, and my mind started to go around all night long, and finally I got it. It was a really interesting experience.
Awesome. Thank you so much for sharing that. Really cool. I actually, I think I only made, there's only one night where I did not sleep. I mean, outside of traveling to Las Vegas, because there's like a layover, but I still slept a little bit. And there's like my 20th birthday was like the literally only time where I skipped the night, and it was a horrible experience. Like I like the next day was shit. But yeah, thank you so much, Giovanni, for being on the podcast. Before I let you go, what's the number one place where they can find you and more about the Power Law?
So X is probably the place where I am more prolific. So if you want to put my X link, but I also have a website that is called BitPoseidon. So BIT Poseidon, like the god, .com. Poseidon because of the waves, right? Riding Bitcoin waves. But that is a site that I'm trying to have as a kind of point of reference. I have a newsletter so people can sign up for. I have links to my indicators. I made like 15 different indicators on TradingView that people can use. So that is a good place where to go. There are videos. I will upload actually this video when you post it. It's a reference point. So bitposeidon.com.
Awesome. Thank you so much, Giovanni, for taking the time and
My pleasure.
Being the record episode for the longest one right now. I think you have the two longest episodes actually on my podcast. So it's always a pleasure talking with you. And yeah, thank you so much also for everyone that is watching and listening, for joining us today. As always, I'll be back tomorrow with another episode. Bye-bye.
Bye, everybody.